Very good morning to one and all. Being the first class of digital electronics, so I would like to explain to you what we are going to see in this entire semester. Okay, the course name is Digital Electronics, and there is an objective given over here. Okay, so you're going to learn about the digital characteristics of electronic devices and especially the logic gates and how these gates are combined together to make the circuits. And of course, we'll see some simplification methodologies also. Okay. And once this course has been completed, what is the course outcome? Okay, a student is expected to have. Okay, so you can understand different number systems which are used in different devices, and you will be able to understand the code conversion. So when you say code conversion, the language which we speak, okay, it's a high level language. Maybe you can see that say that some may use C language, some may use Java. Okay, there are many high level languages, but the computer system can understand only one. Okay, that is the bits or the bytes. Okay, zeros and ones. In that also there are many codes. Okay, in school level we might have studied decimal number system, hexadecimal number system, like that. Okay, so one code can be converted into another type of code using logic gates, so that also we will see. And the third one is that, like, there are two basic types of digital circuits. One we call it as a combinational circuit, the other one is called as a sequential circuit. Okay, so this is going to be your fourth and fifth unit, how these circuits are differ. Okay, operation wise, how they are differing, the way in which they take the input, how they are going to differ. Okay, so this we will see, and we'll be able to construct, means we are able to design the different digital circuits. Okay, so this is the course outcome once you finish your digital electronics paper. All right. And the first unit, there are 5 units as in every course is having. The first unit is with your number system. Okay, number system, from our primary education, we were learning about what is a number system, like a decimal number system, binary number system, hexadecimal number system, and there are many octal number system. Okay, that is some number system are human understandable. Decimal, it's actually base 10. Everybody, or we can say the radix 10. Everybody can understand. Okay. But the system can understand only one, that is binary number system. Okay. That's a base 2. Okay. This unit, okay, so for few of you, you might have studied how to convert one number system to another number system. For most of us, it is new. Okay. So what are the number systems? Binary, octal, hexadecimal, and decimal number system. Okay. So converting from one number system to the other number system, and then using that number system, how to perform arithmetic operation. So when you say arithmetic operation, hardly there are 4. Okay. Addition, subtraction, multiplication, and the division, isn't it? But the funniest part is that a computer can do subtraction, can do multiplication, can do division only in the form of addition. Okay, so how, why? Okay, so like multiplication. So when we say 2 into 3, the answer is 6. But when we learned, how we learned when we were kids, 2 plus 2 plus 2. Okay, 3 times that 2 was added together to get the product, to get the multiplication. So same thing happens here also. Okay, and subtraction also will be done in a form of addition. That's called complement. One's complement and two's complement. Okay, so that is what we are going to see in the first unit. And how about the second unit? So second unit deals with BCD, binary coded decimal number. Okay, that is full of binary. Now this is code. Like the in C language, we might have heard about ANSI and then ASCII codes and all. Okay, so here we have grayscale, otherwise we can call it as a gray code, and then BCD code, and we have XS3 code, XS3 code, and then we have EBCDIC code also, extended binary coded decimal. Okay, so these are the codes. Of course, we have ASCII code. So when I press a keyboard, when I press a key in a keyboard, okay, for example, now I'm pressing A. What is a value a system can understand? Is it going to be an alphabet A, or is it going to be some value? Obviously, it is going to be some ASCII value. Okay, how this character has been converted into ASCII code? We have code conversion circuits. It's all built in. When you say a computer system, it's all built in. These circuits are actually built in. Okay, so with this too. And then we slowly move on to the introduction to digital electronics, wherein we start from a logic gate. Okay, so whenever you take any of the appliances, any of your digital appliances, you take a remote or a TV or a washing machine, okay, or an AC, the end of that particular product is going to be one IC, a black color integrated chip or a black color integrated circuit. What is it actually? Okay, that is having n number of circuits inside that which performs a specific operation. We call that as IC, integrated circuit or integrated chip. What does that chip has? Okay, the chip is actually going to have some logic gates. Logic gates, as I can say, that that's a simplest or that's a basic electronic device. You cannot deduce it further. Okay, so that is called a small circuit which can perform one specific operation is what we call it as a logic gate. Okay, one IC, how many logic gates can be there? Okay, it is as simple as 4 logic gates, or it can be tens and thousands of logic gates are also be there. So depending upon the number of ICs, number of gates, okay, it can be a small scale or a medium scale or a very large scale integration, VLSI. All right. And the third unit is that simplification of circuits. So when we have circuits, okay, it's not like always we'll be having some humongous amount of circuits over there. We can reduce all those circuits, simplify in a very logical way. Okay, it doesn't mean that you make a circuit, a very huge circuit, and then we dismantle it, and then we make a small circuit in a simple way. No, we have mathematical calculation for that. Okay, maths is a basic for all sciences, including electronics also. Okay, so how to simplify the circuit? We have, excuse me, we have 3 ways to simplify the circuit. One is applying De Morgan's theorem. Okay, using De Morgan's law or De Morgan's theorem, any given equation, when I say equation, a circuit is given in a form of an equation. Okay, so any equation can be simplified using De Morgan's theorem. And the second one is that we call it as Boolean postulates. Some of you might have studied in your standard mathematics, Boolean postulates. Okay, using Boolean laws, any given circuit, any given equation can be simplified. And the third one is called K-map, otherwise called Connacht's map. Okay, rows and columns will be there. So using that Connacht's map, any equation can be simplified. All right. So these are the 3 ways in which a given equation, otherwise equation is nothing but a very big circuit. Okay. So that can be simplified. So that we will see it in the unit 3. Unit 3 is going to be full calculations and we need to work out properly. All right. Coming back to unit 4, I told you there are 2 types of circuit, isn't it? One is combinational circuit and the other one is actually sequential circuit. Okay. So this combination circuit, it's going to be very interesting because whatever you see in a real-time application, every circuit, okay, you take a washing machine, you take a TV, a refrigerator, everything can be either be consolidated as a combinational circuit device or it can be a sequential circuit. Okay, so that's some of the example I can give it over here is one adder circuit. Adding numbers. When I say 2 plus 2, you make a mental mathematics, say, okay, but we have a circuit to take input and then add it. So we call it as an adder circuit. When adder circuit is there, obviously we have subtractor circuit also. So we'll be seeing about full adder, half adder, full subtractor and half subtractor. And then there is something called parallel adder. Parallel adder in the sense like parallelly adding 2 numbers. For example, first number is added with the first number, second is added with second, third bit is added with the third bit, and the fourth bit added with the fourth bit. So this is called parallel adder. Okay. And then we have comparator circuit. Generally, when you compare 2 numbers, what will be the effect of it? Either it can be equal to, less than, or greater than. We do have a circuit. Okay, that's called as a comparator circuit. And then we have encoder decoder circuits. This is the one which I told you in the second unit, converting one code into another code. We have a digital circuit. So the circuit which converts a known form into unknown form, that's called as encoding. Okay, hiding something. Okay, the reverse of is actually called as a decoder. Okay, so converting it from unknown form to the known form is called as a decoder. And the last 2 circuits are multiplexer and demultiplexer. Multiplexer, the meaning is at one to many, and the demultiplexer is the reverse of it. Okay, so this is called, these circuits are actually called as combinational circuits. All right. And the last unit deals with a sequential circuit. Sequential circuit, what do you mean that it deals with a memory unit? Okay, so what and all we are going to see here, or we'll be seeing in the practical, is just going to be your CPU, Central Processing Unit. What and all the CPU can do, it can process something. That's what we have seen in the fourth unit, or we are going to see in the fourth unit. After that, what does that computer do? What does the CPU do? It can store something in the memory. So that's what in the fifth unit. Okay, so registers, or we flip-flops, okay, combination of flip-flops are called as the registers. Registers are the basic unit which can store the data. All right. So there are many types of registers and flip-flops. Okay. So I don't want to make you confused now itself, but we will be seeing it in the end of this unit 5. Okay. And we do have some textbooks which are prescribed to you, and you have your LMS content also. Okay. And this course goes along with your practical sessions also. Okay, so hands-on practical sessions will be there. We used to call it as an electronic kit. We cannot give the CPU to you directly to make you, okay, then make a wire and then make the CPU add two numbers. That's impossible. So what we have done is that your seniors have already built in some kit, KIT, electronic kit, okay, which is a simulation of your CPU. Okay, you can use that, and we can make the connections over there so that you can do the operations, logical and arithmetic operation that a CPU can do. Okay. Now, the first class which I want to go is that I'm skipping off the first two units. And in the next class, we'll be going into the digital electronics directly. And we'll start with the De Morgan's theorem of how a simple or how an equation can be simplified using De Morgan's theorem. Okay. So with that, I'll end the class. See you in the next class.